Welcome to the first Aleph tutorial on YouTube. Aleph is a next-generation scientific computing programming language with a bright future. And in this video, I'm going to share with you some basics, basically a crash course in Aleph to get you started using it. The first thing to note about Aleph is that it supports 5 primitive data types. The first one are booleans. So these can be true or false or 0 or 1. The next data type is the integer data type. So for those more familiar with programming, these are signed integers. Next are real numbers. So these are numbers with decimal places. And then of course we support complex numbers like that. And finally, we support strings as primitive data types. Just click here and run that, make sure all of our syntax is fine, and you see that it ran. Okay, there's a couple things that are going on here that are interesting and should be clarified. Variables, when you first declare them, so the first time when you declare them, you have to give them a name, but you also have to start with var. You can of course change the variable's value later on, so I can say vbool is equal to false. But something that's unique about Aleph compared to something like, let's say, Mathematica or Python is you can't change its type. So I can't then go and say, this is equal to, I'm now a string. Vbool is a Boolean for the lifetime of the program. If you want a new string, you need to store it in a data type that is specifically set to string. So this line of code won't work, but if I do this now, the program will throw an error. I tried to cast a Boolean to a string. So let's delete this line. You can always ask the program for the type of a variable. So if I ask for type name, these brackets are actually optional. There you go. It prints out that this is a bool. I can start variables by just saying var x, and at the time of initialization this doesn't have a type. But if I then say x is equal to 1, the program will interpret this as an integer. So at initialization, saying something like 1 or 1.0 is going to change the behavior of the program. 1 means integer. Mathematically, this behaves as an integer, and 1.0 is a real number. Another thing that you should keep in mind, especially for memory management reasons, a lot of problems at the forefront of scientific computing is sort of memory handling and making sure you get rid of memory you're no longer using. To do this in Aleph is pretty easy. Unlike Python, it is not a garbage collected program. Instead, it is scoped. And we have well-defined object lifetimes. So for example, when I declare var x is equal to 1.0, this is in the global scope. X is going to survive until the end of the program. So when I click play, up here until the very end, x is going to be in memory. However, if I create a scope, which is common inside functions or for loops or other sort of logic blocks, I create a variable in here, this is now going to exist until the end of the scope. And so the scope is defined as the beginning of the curly brace to the ending of the curly brace. So if I attempt to print a, outside of this scope, what we're going to find is that we get an error. So this function, this variable does not exist in the global scope. At the moment we crossed the boundary on line 7 of this curly brace, it was deleted from the program. So this is an important aspect of Aleph. Because it's designed for scientific computing workflows, all we're doing is we're guaranteeing you well-defined object lifetime. Aleph also comes standard with all of the control flows that you would expect, if-else statements, for loops, etc. So for example, I'm just copy and pasting this in. If I ask for a variable x and I set it equal to 2, I might want to check as a toy problem to see where it is. Is it a small number? Is it a medium number? Or is it a large number? So here I'm asking, is x greater than 10? If else or else if, maybe it's between 5 and 10, and else it's a small number. Sure, you can do that in your head. X is a small number. These blocks work as you would expect. The first thing it's going to check is the if statement. If this code ends up getting executed because the if is true, then these blocks will be skipped. The next thing that we can look at are for loops. So there's two main types of for loops. There's also while loops, but this video is not meant to be a comprehensive video. It's just supposed to get you started so that you can do very common things. So the two different types of for loops are C style and Python style range-based for loops. So the first style is a C style for loop. And basically the idea here is that I declare the variable that I'm going to iterate over. I tell you its range, and I tell you how I'm going to iterate. The next for loop, and we'll press play eventually, it's going to print out what I is. The next for loop is a Python style for loop. So in Python, you can often say for I in this array. So this right here on the right-hand side of the colon is an Aleph list. And we're going to get to lists actually right after this, but the idea here is that I will just iteratively go over everything inside this list. So let's do this. You can actually initialize lists in a cleaner way, for example, if you wanted, for example, all the numbers from 0 to 5, non-inclusive. So this for loop is now equivalent to this for loop. What this is going to do is it's going to initialize a list from 0 to 4. So next, let's quickly talk about lists. Lists are the sort of the base data type that you might use to store different objects. And the interesting thing here is that it's not, each entry could be a different data type. So for example, I can always print off a list very quickly. The interesting thing about the list behavior though, the list will guarantee type safety. So if I was to try and change the first entry or the 0th entry to a new number, I could write 2. So this would, as you saw previously, might be considered an integer, but we can convert integers into real numbers if we have to. And this should be fine. But what I can't do is I can't change the type of the entry. So I can't say this is now hello. This will be an error. There's no sort of acceptable conversion between hello and real numbers. This is not accepted. There's a number of operations that you can do to lists, but one common thing is that you can add things to the back of the list to extend it. So if I run that, let's actually just print it so you can see the result. You get this. So while we're here, I think it's worthwhile to note that you can go to the docs and see every member function, every function that acts on a list by just going here. So if I go to list, I can get the main entry point for list objects, get a quick example, get all of the ways that I might construct a list, symbols that act on them. So specifically, you can set things equal to lists, or you can modify entries of it. And then you get a comprehensive list of every function that acts on a list. And this is true for all of our data types. So when you start getting more into scientific computing workflows for linear algebra, quantum many-body physics, etc., and you're wondering what's actually available, there's a couple ways to go about learning about different data types and how to use them. The most comprehensive way, though, is always to go into the library reference, but it might be easier to get started by going into the Learning Center for tutorials or concepts where we deep dive topics. The last thing that I wanted to cover in our crash course is functions. So functions in Aleph are interesting because they can either be type safe or not type safe. So a little bit like Python, if I write def func1 and I accept a, let's do something really simple and return a +1, okay? So in this program, I'm not telling Aleph what a might be. The only thing that I need to guarantee is that this operation makes sense when I pass a to the function. Now, because we have our eye on a strong compatibility future with modern compilers and making sure that your code can be compiled and be very optimized, what you can do instead, though, is you can ask for a type-safe version of your code, and you can tell Aleph what data type it's expecting. So again, we're going to return a +1. So now let's make a variable y that we intend to pass to the function. And something just to say is that when you pass something to Aleph, this a may be modified. Things are passed by reference by default. We don't have a const keyword yet to tell the program that you are not allowed to modify the variable. So you should be careful when passing something. You shouldn't modify it unless you fully intend to. So if I ask for y to be 1.5, I can pass, I'm just going to print out the result. I can pass this to func1, y here like this, right? And what this is going to do is it's going to return a +1, which is 2.5. This makes sense, right? The thing is, though, is that if I was to instead try to pass it to func2, Aleph is going to throw it an error, because y is initialized as a real number because I declared it to be 1.5. To rectify this or to use this code safely, you might want to instead declare y to be an integer if this is the desired behavior and you get 2. So this is it for the crash course, but if you want to learn more, go to the Kothar docs, and to learn the language basics, so sort of the things that exist to help scientific computing and for you to express ideas and algorithms, go to the docs and read Aleph 101. There's a lot of things that I didn't cover in here. So for one, you can declare variables that are global and scope independent. So if you're inside a scope and you want to declare a new variable for a variety of reasons, globals will always exist in the global scope. Other things that I didn't cover are things like switch statements. I didn't cover while loops. I didn't go into depth for things like strings or slicing different containers like lists. And I didn't go into any type of fancy string formatting. I didn't touch on maps, sets, or pairs. I also didn't cover things like anonymous functions or lambdas, mathematical operations, classes, etc. So there's a lot to learn here, and there's a lot of guarantees that we give you with numbers and operations that would be useful for you to understand. So definitely take a deeper dive. But this will hopefully get you started and make it easier for you to start reading concepts and tutorials for you to deep dive the type of scientific computing problems that you want to study. But that's it for today. I appreciate you watching the video to the end. Don't forget to like, subscribe, and leave a comment below.